Alright, so let U be the set of all letters in the English language, and just because not everyone's a native English speaker or a native Roman alphabet user, we know that that's going to be 26. Alright, how many subsets of 7 letters contain the vowel A? So it's actually the same sort of questions we were just talking about, but a bit more advanced. So, because one of the problems here is, so when I was talking, how do you choose exactly 2 elements? It's a nasty thing to try and do, and you gotta sort of correct yourself if you're going to do it in a 1.3 way. And that's one of the reasons we create some new notation. So let's think about my set of alphabet letters, so A, B, C. How does the alphabet end? Y, Z. There we go. Okay. So what do I want? I want a subset. I have to have the vowel A. Okay. So I'm creating my brand new subset. A's got to be in there. No choice. Well, I guess you could say one choice. You have to choose A. So one choice there. But then I need to have how many others? I need 6 other letters. Okay. I can't use A again. A's already in the set, but I've got 25 left to pick from. And I need to choose 6 of those letters. Okay. Now you could do the same, well, I've got 25 choices times 24 choices times 23, and then you'd have to do this massive correction, because sets don't care about order. Or you could use the notation we have. If you've got 25 things and you need to choose 6 different ones, we've got oops, not a fraction. We've got notation for that. 25, choose 6. And that's what we learned in 1.5. Nice, simple notation to easily work out a question like this. Okay. So 25, choose 6. And while we're at it, we can do the B part here. How many subsets of exactly 5 letters contain at most 3 of the 5 vowels? So this at most language gets me thinking, okay, we're not so good, if you haven't noticed, with our formulas and our techniques of saying at most or at least. So this I would break into cases. Okay. So I need a subset of size 5. Okay. I need to use at most 3 of the 5 vowels. And just for future reference, which are the 5 vowels? A, E, I, O, and U. Okay. And now, somebody, I assume somebody who's trying to get their English degree currently, is about to say, what about Y? Isn't Y a vowel? And I've been asked this so many times, I would like to formally state, for those of you who care, Y is not a vowel. Y is what is called a semi-consonant. It is a special designation. It does basically act like a vowel a lot of the time, but not always. Technically, it's called a semi-consonant. So you learned something that isn't math today. You can smugly tell people that, if they're saying they're getting their English lit degree. You can say, Y is a semi-consonant. Anyway, those are the ones, A, E, I, O, and U. Okay. So what do I need? I need at most 3. So what could I possibly have? Well, I could have exactly 0 vowels. Okay. I could have exactly 1 vowel. Or I could have exactly 2 vowels. Or I could have exactly 3 vowels, right? At most 3. So I couldn't have 4, I couldn't have 5 vowels. Okay. Now, if I've got exactly 0 vowels, I've got to pick 5 letters from the remaining 21 consonants and semi-consonants. Okay, so what can I do? I'm going to, from my 5 vowels, pick none of them. 5, choose 0. And then, so that's why I'm multiplying, from the 21 other letters, however you want to classify them, I need to pick 5 of them. Right? We're making a set of size 5. Okay, so if I pick exactly 1 vowel, that means I have to have 4 non-vowels. So I pick 1 out of my 5 vowels, 5 choose 1, and then of the 21 non-vowels, I have to pick 4 of them, and these letters will all go into my new set. If I've got 2 vowels, that means I'm going to have how many non-vowels in my set? 3. So I have to pick 3 of the 21 non-vowels to add to my set. If I've got exactly 5 vowels, let's pick which of those vowels I'm using. I've got 5 vowels to pick from. I need to have exactly 3 of them. And then, Okay? That leaves 2 non-vowels to pick. Okay? And these ors then fill it in and say, okay, you looked at completely different cases. Just add them up, and there you go. Is that the only way to answer the question? Absolutely not. Okay? You could have, instead of saying, all right, let's break it down into exactly 0, exactly 1, exactly 2, exactly 3, you could have figured out the number of ways to use any number of vowels and taken away the cases where you use all 5 and exactly 4 of the vowels. That would be another approach, but this is a perfectly good answer, as is. Okay. Questions or concerns on any part of, what was that, 7? There you go. Somebody's asking for number 4 there. Any clarification on putting it together? I really like sort of emphasizing we're breaking it down into I can do exactly this, I can do exactly that, I can do exactly that, or I can do exactly that, because we're good at exactly. We are terrible at mosts and at leasts. But if I know exactly how many vowels I want, then I can pick them, and I know exactly how many non-vowels I want. Okay? This is where the formulas really start to shine. Okay? I'm sure the number is quite big, but that's why we don't do anything with calculators. Okay? You would leave your answer exactly like this.